Solving compound inequalities. What if you're given a compound inequality and are asked to solve it? If given an inequality that has an intersection, such as 4 is less than or equal to x plus 2, which is less than or equal to 8, break it into two inequalities, adding an and to the inequalities. Each inequality is then solved and can be graphed. If given an inequality that does not have an intersection, such as this, solve each one separately, as this requires an OR statement. Then graph the union of the two inequalities. Solve this compound inequality. 4 is less than or equal to x plus 2, which is less than or equal to 8. First, we rewrite it as two separate inequalities. Then we solve each inequality for x. So this one, we're going to subtract 2 from both sides, and we get x is greater than or equal to 2. And over here, we also subtract 2 from both sides, and we get x is less than or equal to 6. We can combine them and graph the solution. This can also be solved without separating the two inequalities. Just perform the same operation by subtracting 2 from each of the three parts of the compound inequality. Solve this compound inequality. 2 plus r is less than 12, or r plus 5 is greater than 19. Solve each one separately, but since this is an OR statement, graph their union as they don't intersect. So here we're going to subtract 2 from both sides, and we get r is less than 10, shown here. Or here we're going to subtract 5 from both sides, and we get r is greater than 14, shown here. Solve this inequality and graph it. -9 is less than x minus 10, which is less than 5. We can solve each part separately or at the same time. Essentially, we can break it up into two inequalities and solve for x, in which case we're going to be adding 10 to the other side in both of the inequalities. So we get 1 is less than x and x is less than 15, which can be combined and graphed as shown. Solve this inequality and graph it. 7x is greater than or equal to 21, or 2x is less than or equal to -2. This is an OR compound inequality, so solve each individual inequality separately. Then graph their union, as there's no intersection of the solution sets. Here, in this one, we're going to divide both sides by 7, and we get x is greater than or equal to 3. Over here, we're going to divide both sides by 2, and we get x is less than or equal to -1. Solve and graph the solution set. -18 is less than 3x minus 6, which is less than or equal to -3. First, I'm going to add 6 to both sides. And so that's going to give me -18 plus 6, which is -12, is less than 3x. I'm also adding 6 here to get rid of it. Is less than or equal to -3 plus 6 is +3. Then I'm going to divide each piece by 3, and we get -4 is less than x is less than or equal to 1. So -4, all right, so x is greater than -4, however, it is less than or equal to 1. And there's the answer. Here, we're going to solve this for x. So we're going to subtract 2 from both sides, and I'm going to rewrite it over here. -5x is greater than 25. Then we're going to divide by -5. Now, anytime you divide by a negative, you have to flip the sign. So this becomes x is less than -5. Over here, we have x. We're going to add 3 to both sides, so that gives us x is greater than 5. So x is greater than 5, and, or x is less than -5. And here are the solutions. -2x minus 6 is greater than 4, or x plus 5 is greater than 8. All right, here we're going to start by adding 6 to both sides. I'm going to continue it up here. All right, then we're going to divide both sides by -2, which means we do have to flip the sign around. X is less than -5. Here we're just going to subtract 5 from both sides, giving us x is greater than 3. So negative 5, x is less than that, or x is greater than 3. Here, negative 6 is less than or equal to 2x plus 4, which is less than 10. First, we subtract negative 4 from every part. That gives us negative 10 less than or equal to 2x less than 6. Finally, we divide all three parts by 2 to get negative 5 is less than or equal to x, which is less than 3. Negative 5 gets a solid circle, 3 gets an open circle, and then we connect the dots. And here are the solutions.